In this video, I'm going to talk about problem set number 3 and strategies on how to solve things. Um, Basically, I'll walk you through many, if not most, of the steps on solving it, and then I'll leave a few elements out that you can solve. The idea, again, with the problem sets is that it's a safe space for you to work through problems so that when you get to the exam, you understand things a little bit better. So let's look at the first question. Here we've got two different markets with obviously two different demand curves, but similar costs because it's the exact same product that's being sold. And then in one case, we need to solve for what it would be if they can price discriminate versus if they cannot. Okay, so we're given two inverse demand curves. And we already know that we're going to be solving for marginal revenue equals marginal cost. So we're going to find the marginal cost here. Here we see that it's 5 plus 3 Q1 plus 3 Q2, basically 5 plus 3 Q. These are just the two individual markets. That would mean the marginal cost is just 3. Now, what we know is that when we have an inverse demand curve, like we do here, where P is on the left-hand side of the equation, then marginal revenue is twice as steep. So that would mean in market 1, we would have 15 minus 2Q1 equaling 3. And then you can obviously solve for Q1. And then I'll let you solve for market 2, but it'd just be the marginal revenue would be twice as steep, and it would equal marginal cost, which is 3. So then solve for Q2. Then you need to add these two Q's together, Q1 and plus Q2, to basically solve for a big Q. And the reason why you're solving for that big Q is that you're then going to solve for the price. You're going to use your number here and your number here. So your 15 plus whatever number you found here for Q1, that's going to equal your price one. P2 is going to equal your 25. Sorry, not plus, minus. 25 minus your Q2 that you found over here. So now I'm going to know the individual prices in each of the markets. I'm going to know the individual quantities in the markets, and I'm going to know the total market quantity by having added them. Okay, so we know what it's then like for the price and the output, at least, if they can price discriminate. Now we need to find the profits. When we found the marginal revenues, we found that as twice as steep, and we still need to find the deadweight loss. In the case of, insert a new slide here. Okay. So now we need to find, still on number 1 here, total revenue minus total cost is going to give us the profit levels. Total revenue is going to be your P1 times your Q1 that you found, plus your P2 times your Q2. Total cost, well, we were given that in the original equation. It would be 5 plus 3 times that total Q that you found, which again was the addition of Q1 and plus Q2. And you're just going to subtract these two to find the total profit. And then you need to find the deadweight losses. The equation for the deadweight loss would be 1/2 base times height. Um, in the case of, it's usually helpful to draw this out. And so again, you're finding marginal revenue equals marginal cost and then going up to the price to find the price charged. And you're going to be solving for that this is going to reflect that reduction in quantity. We know you essentially need to find this number, this number, this number, and this number. Using your demand equation, using your marginal revenue equals marginal cost. So for instance, for marginal revenue equals marginal cost, we actually already found that this number is 6. And we found that this price was 9. Now what's this number? It's 3 because the marginal cost is 3 at that point. What's this number? Well, you can put 3 into the demand function, the original demand function. Subtract 15, that's going to give me negative 12 equals negative Q1 multiplied by negative 1. 12 equals Q1, so this is 12. Here's the base of my triangle. Here's the height of my triangle. So it's going to be 1/2. Then you're going to do this again for the second market. I just did it for you for the first market. And then you're going to add those two together. That's going to give you the total deadweight loss. Now, if we go back here, then we're going to be asked if the law prohibits charging, to solve for all this again, if the law prohibits charging different prices in the two regions. So if that's the case, um, I'm okay with you, just given the nature of the time that we have left in this course. Um, I'm okay with you just talking about it in general. Um, would you, basically, you could tell me, would you expect the price to be, if it was a single price, would it be higher or lower than the P1 price, or higher than lower than the P2 price that you already found? And what about the quantity? Would the quantity be higher or lower in general? We would find that the um, quantity would be higher. Sorry, we would find that the quantity would be higher if they're allowed to price discriminate. Otherwise, they're going to act like a single price monopolist. And as a single price monopolist, what we know is that we could add these two demand functions together, giving you 40 minus 3q. So that would give you 40 minus 6q equals 3 as your marginal revenue equals marginal cost. And then you could solve for q and then solve for p. Oh shit, I just solved it for you, so I guess let's write it out here. Okay, so if there's no price discrimination, then it's going to be 40 minus 3q as my demand. Which would mean that my marginal revenue marginal cost is still equal to 3. Something, right? And then P would equal 40 minus 3 times 6 something something. So it's going to give me 12 something something something. Quantity is indeed lower. Price is indeed higher. Okay, let's go back. And now let's look at number 2. So now we need to find reaction functions and the Corneal equilibrium. So let's start to, here's our equations. Let's start to look at that. Okay, so the idea here is that for number 2, so this Q, again, is essentially Q1 plus Q2. And the first thing we're going to do is we're going to find marginal revenue equals marginal cost. These are the steps we're going to need to find the reaction functions. Total revenue for firm 1 then would be P1 times Q1. That would be 50 minus 0.5 Q1, right? Because the price is given to us right here. This is a Q, which again is the summation of Q1 and Q2. and this is a Q1. So make sure you keep these separate because this is actually additive. You're going to see what kind of happens here. Now I'm going to multiply out. So it's going to give me 50 Q1 minus 0.5 Q1 plus Q2 Q1. So it's going to give me 50 Q1 minus 0.5 Q1 squared plus 0.5 Q1 Q2. And then if I want to find the marginal revenue, I need to take the first order partial derivative of this function. So that's going to give me 50 minus Q1, because this 2 goes out in front, and then it's, right, so it's just Q1 sorry, I made a math error here. Sorry, just a sign error. Negative, should be a negative Q1, Q2. Okay. There's my marginal revenue. Now, to get the reaction function, I need to set this marginal revenue equal to the marginal cost. So let's just so to get the reaction function, yeah, it's horrible, sorry. So I'm going to use the marginal revenue I just found, 50 minus Q1 minus 0.5 Q2 equaling 0. It equals 0 because I just told you here marginal cost of 0. Okay, and if you do that, I'm just going to simplify it here. Q1 is going to equal negative, or sorry, just 50 minus 0.5 Q2. Sorry, plus. That one would be a plus. Then, no, sorry. I don't know why I said that. Sorry about that. It's a minus. Right? Now I just feel like I should do it. Let's see. There you go. Okay, so this right here is my reaction function. It tells me how firm 1 will react based on what firm 2 is doing. I would need to repeat these steps again for firm 2 to find firm 2's reaction function. I'm going to make you solve it, but I'm going to give you the end result here. That way you'll know that you did it correctly. Q2 equals 50 minus 0.5 Q1. We shouldn't be too surprised by this because they face the exact same marginal cost. You'll need to solve this still, and I will look that you have. Now, the question then becomes, what do you do with these reaction functions? Well, you're basically going to put them into each other to find the Corneal equilibrium points, the Corneal quantities. Let's get another slide here. So that would mean for the Corneal, see what I'm doing here? Q2 is equal to 50 minus 0.5 Q1. What I did is I used, this is that reaction function I just did solved for. The reason why I did that is it gets rid of one of my unknowns. Now I can just solve for Q2. Right, just taking the 0.5 times each of these. Oh, you solve that. That's just putting it in your calculator, essentially. Fuck it, I'll just tell you. Now, you do it then for from 1. Basically repeat these steps, except now use Q1. And then here you're going to put from 2's reaction function. And that's going to give you Q1. You add those together, and that's going to give you the total market quantity. And if you take that total market quantity and put it into our P equaling 50 minus 0.5 Q, if you take that total market quantity and put it into here, you'll then find the price, which is the other question asked of you, the Corneal equilibrium quantity and price. Okay, number 3. Here, we are solving it as if these firms are monopolistically competitive. If they are monopolistically competitive, what we know is that they're not going to, this would be a long run equilibrium if the profit level is 0. So, in some sense, this hopefully should be a pretty easy, to solve. Let's start to do that. The inverse demand function is this. That would mean that my marginal revenue, which is twice as steep as this, would be 500 minus 19.5 QD. The cost function is 0.25. I believe it is 0.25 Q squared. That would mean that my marginal cost is 0.5 Q, right? Because this would no longer exist. The 2 goes out in front, Q, and then 1 left over. Okay, I've set up my marginal revenue and marginal cost. I won't solve the solve for you here, but set MR equal to MC to find the quantity. And then substitute that quantity into that to find the price. You'll know you've done it right if your total revenue equals your total cost. Total revenue would simply be your price times your quantity. Your total costs is this function, so you're simply going to insert your quantity here, square it, multiply by 0.25, add 6250. I got the same number, which is a sign that this would then be for a monopolistically competitive firm, the long run equilibrium. Okay, let's look at number 4. So now in number 4, we need to find what the price would be, quantity and price would be if they were single price monopolist versus perfectly competitive. Um, okay. So there's my demand function. My marginal revenue would then be twice as steep as this. I say in the question that the marginal cost is 0. And you set MR equal to MC, so that would mean 1200 minus 2Q equals 0. Q equals 600. Right, this is a single price monopolist. I then have to go up to the demand curve to determine the price. That would mean I take this 600, put it in there. How's this looking so far? That would mean, well, essentially the marginal cost is right here as well. And then I go up to the demand curve to find the price of 600. Okay, now, what if the firm was perfectly competitive? How does that change things? Well, what that means is that the marginal revenue would be the same as the demand curve. So my marginal cost isn't going to be any different. Marginal cost is still going to be 0, except my marginal revenue is now going to be 1200 minus Q. But that Q is for both, right, is for, in this case, for this entire market. The marginal revenue the quantity would be 1200 because the marginal revenue is the same as the demand curve if it's perfectly competitive, which basically is the y-intercept of the demand curve. And the price, it'd be 0 because it's going to be the same as the marginal cost. So as you can clearly see, by not price discriminating, the by not allowing this firm to act as a monopolist, you're going to find that the quantity will be higher and the price will be lower. Okay. Now in number 5, the firm is a monopolistically competitive firm, and we need to find the output and price. And again, we're asked, is this a long run equilibrium? It's not a long run equilibrium if the profit is something other than 0. So that's what we're going to have to solve for. Okay, let's solve it. So for the case of number 5, I've got my 225 minus 10p, which I can rearrange into a inverse demand function. Right, and I did that for you right here. My marginal cost is 0.3q. My marginal revenue would be twice as steep as this, so that'd be 22.5 minus 0.2q. Now I'm going to set MR equal to MC like a monopolistically competitive firm does. So it'd be 22.5 minus 0.2q equals 0.3q. Q in my case I found to be 45. And I'm just giving you an incentive to have watched it this far. And then P, you can solve it by substituting that 45 into there. That'll give you a P. Once you found the price and quantity for the monopolistically competitive firm, you then need to find total revenue and total cost. Total revenue equaling P times Q. So simply multiply these two numbers. Total cost, you're going to take your Q of 45 and you're going to put that into the cost function, which is 0.15 times 45 squared, which I got to be 303.75. This total cost, I found it not to be equal to total revenue. I found total revenue to be greater. If there's a positive profit, like I think there is in this case, this would not be a long run equilibrium. Monopolistically competitive firms earn 0 profit in the long run. And that takes us to our last question. I know I kind of make this look easy, but trust me, I did have to handwrite this all out. So it's not like, also I've done these problems for almost 2 decades, so you would hope that I would know it well. This is a true person, James Murray, best man at my wedding. James Murray, economist at the University of Wisconsin. He and I are going to bottle some water, and the marginal costs here are the same. They are 0. And what we're going to need to do here is we're going to find we're going to need to find the reaction functions again to find the quantities. And so let's just start doing that. Okay. Total revenue would be P1Q1. P1 we know that's 90 minus 0.25 Q times Q1. This is the P1, this is the Q1. This Q, remember, is Q1 plus Q2. So now I'm just going to multiply here, 90Q1 minus 0.25 Q1 plus Q2 times Q1 equals 90 Q1 minus 0.25 Q1 squared minus 0.25 Q1 Q2 then if we divide everything by Q1, I would get 90, sorry, not 90 Q1, 90 minus 0.25 Q1 minus 0.25 Q2 you would then need to add and then divide each side by 1.25. And then you would repeat this for firm 2, these same steps. Again, you should have seen this in, what was it? Question number 2. So I'm trying not to give away everything here. You'd repeat that again for firm 2. And then you're going to need to add those quantities together. Go back over here. So then divide each side by 1.25. And trying to think if there's anything else that you would really need to know that I haven't talked about already. My hope is that you'll follow these steps here for the Corneal. So this would be slide 5 and 6. Don't really see anything different that you would need beyond what I've provided. Okay. If anything, I've set it up so that number 6 might be a little bit tougher, but hopefully, again, nothing too weird. I'm going to save this. Okay. And then when I post the video that's explaining this all, I'll also post that PDF so that you can kind of get a clear picture of everything that's going on. Okay. Again, I hope that helps. I hope you don't feel I cheated you out of taking it all the way, but hopefully it should be enough that you can kind of get through the problem set. And then obviously when it comes to the exam, the questions will be kind of inspired by what was contained within the problem set.